Welcome to springlib.
Part A of problem number 22, we can write a delta x using Lorentz transformation. So we will write gamma into delta x minus velocity times delta t. Then we write a gamma in terms of a beta. We have a delta x which is 400, and then we subtract with this from the velocity, which is 299.8 times a beta over, so this is not clear, beta, sorry, over square root of 1 minus beta squared. So this is that gamma factor that is multiplied. If we plot in part B, if we plot delta x, so here we have a beta, here we have 0.01, so we plot up to 0.01, and here we have 400. We keep, and here we have y-axis, we have a delta x. If we plot the above equation for a beta which is greater than 0 but less than 0.01, so if we plot for this, then the plot we get here is linear dropping here. Part C, if we plot the beta versus delta x dash above equation, beta, for the value greater than 0.01. So here we have 1, and here we have so 0.01. So if we plot for beta which is less than 1 but greater than 0.01, if we plot that 0.01, then we see the graph going down and then crossing the 0 and then shooting up near 1. Part D, so let me open another page. So part D, we are asked to find the minimum for which, what's the value of a beta. If we have, so in order to find the minimum of a delta x at the beta, so we take a derivative with respect to beta of delta x dash. Then if we take the derivative, what we get here is a beta delta x minus c, so this is not c, sorry, delta t over the factor we get here is 1 minus a beta square whole 3 over 2. So we just took the derivative of the delta x that we got on in part A, and we set it is equal to 0 and solve for beta. Then the beta value we get here is c times delta t over delta x. If we plug those values, delta t is 1 microsecond, c the speed of light, and delta x is 400. So 400, this is 1 microsecond times speed of light. This gives us approximately 0.750. This is the value of a beta. Part E, so if we substitute the value of this beta in a part A, so then we will get delta x for the minimum value of a beta, which is 264.8, which is approximately equal to 265. So in this last part, what we did is we found the beta here, and then we plugged this value beta in part A. Then we found a delta x. End of the problem. Thank you for watching.